For this lesson, I want to talk about tubing and piping operations. Remember, the purpose of tubing and piping, it provides a path for refrigerant to take. It sometimes provides a means of return oils to a compressor. It provides a means to supply oil or gas to a heating appliance, and it provides a path for water to take in a hydronic heating system. Proper installations of tubing prevent refrigerant and other fluid loss. Tubing can be cut with a hacksaw or tubing cutter. Tubing cutters for refrigeration lines and smaller tubing, hacksaws for larger diameter pipe and tubing. It removes burrs from tubing after cutting, and all cuts must be perfectly straight. Mark the tubing at the desired cut point, position the tubing on the rollers, and tighten the knob on the cutter until the cutting wheel comes in contact with the tubing. Rotate the cutter around the tubing and tighten the wheel on the cutter. Continue rotating and tightening the knob until the tubing is cut. Maintain a moderate pressure on the wheel at all times to make sure not to over-tighten the knob. In order to bend tubing, you need to use a tubing cutter or a tubing bender that's a bending spring or lever type. Bending springs can be used on either the inside or outside of the tubing. The tubing is secured in the lever bender at the proper position. Then as the handles are pulled together, the bend in the tubing is formed. You can also use your hands to bend. As long as you do it gently, it should not kink. And spring benders can be used as well. They prevent the tubing from kinking. However, all of these things just don't have the same quality as the lever benders. Use them whenever possible. Soldering is the process, as we talked about, of joining piping materials to fittings. It's done in the 500-degree range. You use a filler metal called solder to fill the gap between the pipe and the fitting. Might be 50-50, 50% tin, 50% lead. That's not allowed in Connecticut anymore. And 95% solder is 95% tin and 5% filler or anatomy. Brazing is done in the 800-degree range. Filler material is melted into the gap between the pipe and the fittings. The filler material is called brazing rods, silver solder or hard solder. Brazing alloy contains 15 to 60% silver or phosphorus copper. When you're soldering, pipe is inserted into the fitting, okay, and then you're using a filler material to melt into the gap between the pipe and the fitting. The heat sources for this are usually torches. They can be propane, butane, acetylene, oxyacetylene. The torch kit consists of a fuel tank, a regulator, a hose, and a torch tip. Torch tips are available in a wide range of sizes and styles. To set up the acetylene torch, quickly open and close the tank to get any dirt out of there. Connect the hose and torch to the tank. Make certain the hose torch handle is closed. Open the tank 1/2 turn. Open the torch handle valve and ignite fuel with a spark lighter and adjust the flame. Close all valves and bleed off after use. Okay, so in this picture, they're cleaning out any leftover material. Then attach the regulator. Open the tank once the regulator is attached to 1/2 turn. You should see pressure on the regulator. Check for leaks. You use an air bubble. Use gas leak detector or soap. Once you know you don't have any leaks, ignite the torch and then adjust the flame to what you need it. To solder, clean the end of the pipe as well as the inside of the fitting. Apply flux immediately after the cleaning. Assemble the joint. Heat and apply the solder. Wipe the joint after soldering to remove the excess solder. So first you need to sand it. Get the insides of the fitting. Wipe out any burrs. Use smaller sandpaper if you have to. Apply the flux. Apply heat to the tubing near the fittings. Move the torch and heat the fittings. Keep the torch moving from the tubing to the fitting and heat the entire joint equally. The inner core of the flame, the inner blue side, should just touch the metal. Use the heat of the metal to melt the solder. Do not melt the solder with the torch. Feed solder to fill the joint and don't use excessive amounts of solder. wipe the joint clean. So in this area, in this picture, we're heating the lower joint first. Start with the bottom because heat rises. Heat the lower joint with just the inner blue almost touching the pipe. Once you get it nice and hot, but not overheated, touch the solder to it, as the solder will start to melt and the solder will flow towards the flame. Then move on to the other joint on the pipe. Go to the upper one first. Next, heat it up, solder will start to flow. You might have to bend the solder to get it around the pipe. Once you have it there, once you have enough solder where it's gone all the way around, remove the solder and remove the torch. Allow the solder to cool before moving the pipe and wipe off all excess fluss and carbon buildup. Use a mirror to check the back of the pipes for leaks. To braze, almost the same as soldering. Clean the pipes and the fittings when necessary. Introduce 1 to 2 psi of nitrogen to the piping circuit. In other words, we want to flow some nitrogen through there. It prevents carbon buildup. Light the torch and heat the joint you want to braze. The joint will be at the correct temperature when the joint glows cherry red. Apply the filler material to completely fill the joint. So what we're doing, we have our brazing rod heating up the pipe. Once it's nice a cherry red, the braze will start melting and it will start flowing around the pipe. When it's done, remove the brazing rod. Clean all surfaces. Keep filling and flux from inside the pipe. The filler material will flow towards the heat source. Apply more heat to the fitting if it's not flowing, but don't overheat it. Don't use too much filler material. It will either go into the pipe and create a blockage, or it will look really bad outside. Clean all joints after soldering or brazing. To make flare joints, cut the tubing to the desired length and ream it out. Slip the flare nut over the end of the tubing. Clamp the tube onto the flaring block. Place a yoke over the flaring block and turn the yoke screw down firmly to flare. Remove the yoke and inspect the flare. Put the tube into the flare block. Again, make sure you have your flaring nut on under that, because once it's flared, you will not be able to get it on. Use your flaring tool. Screw down on there until you have a nice flare. Inspect it. Make sure there's no cracks or rough edges. If there are, don't even use it. Make another one. Flare connections go together by you have your flare fitting in the center and you have your 2 flare nuts. They will actually screw onto the fitting. Swagging just involves expanding one section of a tubing to join 2 sections of the same size tubing. Then the joint is soldered or brazed. The depth of the swag should be equal to the diameter of the tubing. A swagging tool and flare block are needed to make a swag joint. Secure the tubing in the flare block. The tube should extend from the block a distance equal to the diameter of the tube plus 1/8 inch. Insert the swagging tool into the end of the tube. Strike the swagging tool with a hammer until the proper shape and length have been obtained. Inspect it. So here's your flare block with the tubing sticking out. Put your swagging tool in and just hit it with the hammer, but try to get it straight or it's going to bend. Make sure you have enough room in the flare block for this whole process to happen. Your swag tool will not expand steel. Once it's done, the section of the same size tubing can be inserted into the swag section. Steel pipe presents another challenge. We can't braze it, we can't solder it, and we can't swag it. So it has to be produced. It's produced without a seam. It can be welded. Most of the steel piping is black pipe or galvanized with zinc coating. It's used in plumbing, hydronic, and heating applications. Pipe size is referred to as nominal pipe size, NPS. Nominal pipe size is approximately equal to the inside diameter of the pipe. When you see the pipe sizes, you will see that it's all labeled as like 1/2 inch. That's your thread diameter. 14, that's the number of threads per square inch, and then NPT stands for National Pipe Taper. Joining steel pipe is joined by using welding or threaded fittings. Most often you will do it by threaded fittings. Taper the ends are used on the pipes and fittings, and taper threads reduce the chance of leaks. There should be 7 perfect threads and 2 imperfect threads for each pipe joint. Pipes can be cut with a hacksaw or pipe cutter. All cuts must be perfectly square. The pipe cutter is a larger version of a tubing cutter that we showed you earlier. Over tightening the pipe cutter can result in formation of a larger burr in the pipe and the shortened life of the cutting wheel. Ream the pipe after its cutting is complete. So to use cutting steel pipe, either a hacksaw or a pipe cutter. To thread it, secure the pipe in a vise. Place the cutting die on the end of the pipe and apply oil. Thread the die onto the pipe using the stock as a ratchet. Turn the die 1 or 2 turns and then back off the die off the pipe a quarter turn. Repeat oiling and threading until the pipe is flush with the far side of the die. Okay, threading stock, put the die on it and turn to create the threads. When the pipe reaches the outer edge of the stock and die, threading is complete. Pipe wrenches are used to hold and turn the pipes and fittings when you're installing them. Apply pipe dope to the male threads of the pipe. Avoid getting dope on the 2 threads on the end of the pipe. Use 2 wrenches to tighten a connection. The wrenches should be positioned in the opposite direction. So as you're putting the pipe dope on, that's the green area, leave the last 2 ends bare, last 2 threads. We also use plastic piping material on occasion, and this is actually becoming increased in use. ABS piping is used for water drains, waste, and venting. It's black. PE is used for water, gas, and irrigation systems. PVC can be used for high and low pressure applications and high and low temperature applications. CPVC can be used at a little bit higher temperature. It can be up to 180 degrees and used for pressures up to 100 psig. So to join a couple pieces of these pipings, cut the pipe square again. Remove any burrs from the end of the pipe and clean the end of the pipe with a primer. Apply cement to the inside of the fittings and the outside of the end of the pipe. Insert the fitting in all the way. Turn the pipe a quarter turn and hold for 1 minute. So you're cutting it. Remove any excess burrs. Apply your cement. Put it together and turn it. Hold the pipe that way for about a minute. So what have we done? We've known that copper tubing can be soft or hard. It's identified as KLM or DWV. It's measured by its outside diameter when it's ACR tubing. Nominal tubing is measured by its inside diameter. Pipe operations include cutting, bending, flaring, soldering, and brazing. Steel pipe can be joined by welding or using threaded fittings. Plastic pipe can be used ABS, PE, PVC, or CPVC, and can be joined by glue.